My topic, which is given to me, is data pre-processing. So before I go into data pre-processing, I just want to introduce about the data that we are um, seeing nowadays, and how we have to know our data. Then we will see some of the statistical distribution. Based on that, we will analyze few data set that are available in real time, and few data pre-processing techniques also I would like to explain, as well as I would like to give you the demonstration in Python. So the first topic is, you should know what all the different types of data which are available in real time. So the data are relational records. We all know many of the applications are started with the relational data, where we are representing the data in the form of structured manner. So where we have the rows and columns, we have every record will be having the will be sharing the same number of features. And this is what our relational records is given right, like this. We have the relationship between the data set and so on. And data matrix, we have the numerical matrix like this. And we have the data in the form of transactions, what are all the items we have purchased in particular transaction. And we have the text data, like we have the unstructured format. We'll be converting the data into structured format by using tokenization method. Then every entries of once we tokenize it, we will get the bag of words. And we as well do certain pre-processing, like removing these stop words, identifying the root words, and so on. Once we identified the words after pre-processing, we will create the structured data set, where all the unique words will be in the columns, and we have every records. And the entries of these records is based on term frequency, term presence, TF, IDF. There are so many methods has been developed in the text processing. We have the text data, which is unstructured. We also represent the data in the form of graphs and networks, where we connect the object by using links, connection between the object to object and sub object, etc. We have the data in the form of data for the application of transportation, world wide web, molecular structures, and our social media, social networks, etc. And we also have the data in the form of ordered structure. The best example is our video data, where we have the sequence of images, and we have the temporal data. How are we going to collect the data in day by day, based on the time. And we have the genetic data, where we have the sequence of genetic information, adenine, thymine, cytosine, and so on. The position of the sequence is very important. So how are we going to handle the ordered data, like these kind of data? And we have the data like spatial, image, and multimedia data. So we have to collect the data with respect to temperature, like weather data, temperature, pressure, and so on. And we also have the video data, image data. So we have the data in various format. The challenge is, how are we going to analyze the data, and how do we get the useful insight from that? So before we get the useful insight from that, we should understand the domain of that particular data. Once we understand the domain, we should able to pre-process the data, so that it can be applied into the machine learning algorithm to make some prediction, or to make some future. We have to get some inference about the data. So the main important thing, we should process, we should analyze, and we should understand the data. So how are we going to do? So whenever you get different kind of data, whenever you have various types of data in your hand, first of all, you should see how I can apply into the machine learning algorithm or deep learning algorithm, and so on. So how do I convert these data into the format that can be applied into machine learning algorithm? So whatever may be the data, text, we need to convert that into the numerical format, image into the numerical format, sequential data into the numerical format. So how are we going to convert that? So once we have the numerical data, how are we going to process it further? So that is the challenging thing. So in every data analytics and artificial intelligence application, if you put more effort on processing the data, definitely you will get better accuracy in your model. So we'll see what are all the numerical data that you need to know. What are different types of numerical data are there? So first one, continuous and discrete data. So if we take the height of the person, weight, salary, temperature, and interest rate, everything can be represented in the form of continuous value. Whereas the numerical data can be described in discrete as well. Say for example, if we have whole numbers like 10, 25, 33. The best example, how many students are there in the class? So you will not say in the continuous value format, you will say 1, 2, 3 whole number. So that is a difference between our continuous and discrete data. So this is coming under our numerical data. The next one is our categorical data. So categories, how can we differentiate into multiple categories? So we usually say this in two types. One is nominal, another one is ordinal. Nominal, it is like we don't have any order, pass or fail. We don't have any order. The climate is sunny, rainy, cloudy. So we don't have any order for that. No concept of ordering amongst the value of that particular attribute. We say it as nominal. Ordinal, if you want to rank the student 1, 2, 3, 4, we have the order. If you have the dress size, you have small, very small, medium, large, very large, extra large, etc. So these two types comes under our categorical data. In numerical data, we have ordinal and ratio scale. So whenever you take the number representation, we have four different types: nominal, ordinal, which is to represent the categorical data, ordinal and ratio to represent the numerical data. And coming to our time series data, so if you take the monthly home sales in the below graph, you can see 10 years how the monthly home sale, the average value of monthly wholesale differs. So that graph is actually represented here. So the difference of time series data and numerical data, uh, we don't have ordering. Time series data does not imply any ordering. That's the difference. So sequence of values are collected in the regular interval over some period of time, and you can analyze those data, which is nothing but our time series data. And I have already given you the details about the text data. So when you want to perform a text review, say if you are purchasing some item, you will go to the search engine and you will look into the reviews given by the users, and you will process those reviews, you will read those reviews, and you will come to the conclusion. But nowadays for one product we could see 4,000, 5,000 reviews. Processing those 5,000 reviews, reading those 5,000 reviews manually is not an easy task. So what we can do, we have to process it. How can we process? We have natural language processing toolkits, we have NLTK, and we can use that package to perform various operations like tokenization, removing the stop words, removing the punctuations, identifying the root words, and converting that unstructured data into the structure format. So all these things we can do it with the text data. So one such application is our sentiment analysis. So identifying the semantic meaning of every reviews and providing the recommendations of that recommendation to the user. So there are many more applications, identifying the fake news, identifying the fake fraudulent emails, and so on. So this is about the data. So we will see the statistical description of the data that we have it in our hand. So here I have one data set. It is the iris data set. There are this is how the data is being represented in terms of table format. We have every records, we say it as cases, and we have the features, we say it as variables. And these are all the features, and this is my target variable. Class is my target variable. Sepal with petal with all are the features. We are going to predict the class based on these features. What are all the different statistical analysis, or how do we analyze the data set that we have it in our hand by using some statistical measures? There are two kinds of statistical methods are there. One is our descriptive statistics, another one is our inferential statistics. Descriptive statistics will just give the summary of the data that we have. The numerical data, say we have mean, median, mode. We can analyze the data based on based on some measures. The descriptive statistic will just give you the summary of the data set. But when we go for inferential statistic, we can draw some inferences from the prediction, or we can do the prediction on the data that we have, and so on. When we do the statistical analysis, we can understand the data in better manner, and we can choose, we can do the pre-processing, and we can apply the machine learning algorithm, predict the future values, and we can also provide the inference on it. So let's see how are we going to do the descriptive statistical measures. So there are two types of descriptive statistical measure. One is measure of central tendency, another one is dispersion measure. So what is the measure of central tendency? Which will give you where the attribute values are, most of the attribute values are falling in. And the dispersion measure will describe how the data are spreaded in your data set. So first of all, we'll see the measure of central tendency, mean, mode, and median, then measure of dispersion. So why are we studying these things? How it can helpful for us for doing data pre-processing? That also I will explain you once I complete this mathematical part. So the measure of central tendency, it mean, mode, median, all these three will give you the single value that best represents our data. So if we take mean, it's an aggregation, like whether the data are packed together. So that is what our central tendency describes. So when you are applying central tendency, you should decide which central tendency method can be applied onto the data. It is all decided based on the scale of measurement. We have seen the data can be represented as nominal. Nominal, we know it is a categorical attribute without any order. Ordinal, we have the categorical attribute represented as an order. We have the continuous value attribute represented as interval and ratio. I will give you the example for difference between interval and ratio. If we take in interval scale, we don't have any zero point. Say if we are measuring the temperature in Celsius or Fahrenheit, there is no 0 point to represent the temperature. 0 degree it's there, below 0 also temperature can be measured. So there is no 0 point. Say for example, room temperature inside the room, let's say it's 26 degree, outside the room let's say it is 42. Say for assume for an example, we cannot say that it is twice the amount of the temperature inside the room. We cannot say that because we don't have any zero true point. But in ratio scale, I can say the height of person A is twice the height of person B. It's because we don't have any negative height, we have the zero true point. So that is the difference between interval and ratio. So we have to use which measure of central tendency we have to use it. That is all based on the scale of measurement, the attribute, how it is being measured, and the shape of the distribution. I will talk about the shape of the distribution in the upcoming slide. It's about skewness as well as kurtosis. I will explain in the later slides. Let me just explain the measure of central tendency. Most of them are knowing it, so I'm just quickly go through it about the mean, mode, and median. So we all know that what is mode, it is the most frequent item. So if we take this particular example, 5 is 5 is occurring 4 times than the other other variable. So then the next item is 6 is occurring 1 time. Yeah, so 5 is the mode here. In this example, if you see, 6 is occurring 4 times and 5 is also occurring 4 times. So it is, you have two modes. So if you have one mode, you can say it as unimodal. If you have two modes, you can say it as bimodal. If you have more than two, you can say it as multimodal. So why these representations are needed, how these mode helps us to do the data pre-processing, we will see with an example. So this is another example. You can go through the slide. When we use mode as an measure, when you use mode to mode as the statistical measure to summarize the data, how can we identify the outliers? So what is outlier, that we need to understand. Outlier is behaving something different than the actual data that we have it in our hand. So how are we going to identify the outliers? All those things we will I will be covering in the upcoming slides. So next one is our median. So we all know that it is the center value. So first of, when you want to calculate median, first of all, we have to arrange the data in order, ascending order. Then we have to identify the middle. Suppose you have even number of values, then you can take the median as average of middle two values. If n is odd number of values, you can take the n value, the odd middle value. I mean, you can take the mid value ECD. So this is how you can find out the median. So let's see an example. First of all, you have to arrange it in an order, ascending order. Here you have 7 values. So this is our median. Here you have even number of values, so we are adding these two and taking an average. Next one is our mean. So it represents the center of distribution. It is commonly used for interval and ratio. So I'll come to the point. When we have the attribute which follows nominal and ordinal data type, we can go with mode and median. Suppose if the attribute is continuous valued, interval or ratio, we can use mean as the statistical measure. So before you apply any statistical measure, before you start doing the statistical analysis on the data, you should understand the data type of each and every feature. So this is how the mean is being calculated. So as I told you, this is a summary. If the data is categorical, you can use mean or median. Okay. If the data is quantitative, you can go with median or mean. So is it right way that every time I can choose mean for continuous value, or the quantitative data, mode for categorical data, which is the right way of doing it? So the second measurement, if you remember, I told based on the distribution of the data, we should decide what kind of central tendency measure we need to use. So the topic is skewness. So I'll tell you, before we move on to skewness, we just want to know, once the central tendencies are identified, we should know how the data are spread from the mean, how it is varying from its central tendency measures. So the variability indicated how spread out the scores are. So we know so many variability measures: standard deviation, we have variance, we have range, we have interquartile range, we have yeah, IQR is interquartile range, and so on. So we will see what are all the variability measures that we have. I am just plotting a graph between two variables. You can see there is high peak over here. which means it is having lesser variation. More number of data are coming in this particular region where the lesser number of values are there. The variations are very less. I could say the variations are very less. Uh, if you take this particular example, you can see the variations are more because more number of values are there in different places. So uh, this is how the variations are being measured. If you have greater variability, it means that there may be an error in the data. So if the measurement errors are larger, we can say that the data are the greater variations in the data. So at that time you should not use mean. Mean is not a suitable measure because you have some outliers in it. So how do I identify those things? If you look into this particular example, we have the data to 0 to 6, 10, 12. The mean is high 6. It is having highest variability. Here the mean value is 6. It is having the closer, it's not that there is no much variations. We can see the data points are much closer. If you take this example, you could see there is no variations at all. So how are we identifying the variation? We are subtracting the mean with each and every data point. Okay, so that is how we are identifying the dispersions. To check the measure of dispersion, as I told you, skewness we need to understand. What do you mean by skewness? I'll take it to the next slide. If you take this particular example, it is symmetric in the both in left and right hand side. Means 50 percentage of the data are distributed in left hand side and distributed in right hand side. I can say it is evenly distributed across the mean. For this, there is no skew. I can say that mean, median, mode are same. So we can say this particular distribution is the symmetric distribution. I can say it is following the normal distribution. When we have the negative skew, which means the data or there is more data in the left hand side. It means that it is not following the normal distribution. There are some outliers after this value 40. Few values are going beyond this particular range. Okay, so I can see this particular part as an outlier, or else sometimes the data are spreaded in the positive direction. So this is negative skew, this is positive skew. So which statistical descriptive measure shall I use if the data follows negative or positive skew? Okay, here uh, we need to understand the property of normal distribution curve. I told you that it is symmetric with respect to its mean, means 50 percentage of the data in the left hand side and 50 percentage of the data in right hand side. So when I say it is normal distribution, you could see the variation. In one standard, sigma represents the standard deviation. In one standard deviation, there should be 68 percentage of the data. In two standard deviation, the spread is 95 percentage of the data. And in three standard deviation, the spread is 99.7 percentage. If the data falls after this three standard deviation, I can say those data are outliers. So this is one of the way you can identify the outliers. Okay, so the next statistical measure, the dispersion of data is range. So what is range? It's a difference between the largest item in the data set minus the smallest item. And we can find the standard deviation. So before you, if you want to find the standard deviation, you should know the value. We should calculate the variance. We all know what is variance, how much the data items are deviating from the mean. So this is a formula for calculating the variance. X is the actual data point minus x bar the whole squared divided by, this is a mean, x bar is our mean, divided by the total number of samples minus 1. I have taken this example and I have calculated the variance as 51.88. So square root of the variance is nothing but our standard deviation. So we can calculate the standard deviation 7.20. This is sigma. So from this sigma, we can identify the normal distribution of the data, how the spread with respect to its mean. In one standard deviation, if we have 68 percentage, in two standard deviation, if we have 95 percentage of the data distributed, I can say same thing for three standard deviation. I can say the data is following normal distribution. Okay. The next one is correlation and covariance. What is correlation and what is covariance? So these two measure will give you the relationship between the attributes. Covariance will say what is the relationship between two attributes. Say for example, if your covariance is positive, it will say that the increase in one attribute make the other attribute value also to get increase, or decrease in one attribute makes the other attribute also to decrease. If the covariance value is negative, which means that increase in one attribute makes the decrement or decrease the value for other attribute. How these covariance helpful in our data pre-processing? So if we want to identify how closer the attribute is, okay, say for example the date of birth and age, if the age and date of birth are closely related. So if the date of birth is increasing, the birth date is increasing, the when you calculate age, that is also gets increasing. So the covariance will if these that covariance will just say the direction of how the change in or the relationship between two attribute, how the change in one attribute affects the other attribute. What is correlation? Correlation is measured from covariance, how strong these two variables are related to each other. Say how much percentage they are strong. If these two attributes are 100 percentage strong, having these two attributes for our analysis makes complex. So you can remove one attribute because these two are redundant. Any one you have to remove. So the correlation and covariance are much useful when you want to select the most relevant feature from your data set. So this is how the covariance is being calculated. Whatever I have discussed, positive covariance, it means both returns. If means one increase in one makes the other to increase. If one decreases, makes the other also to get decrease. So this is about the covariance. Correlation is measured from the covariance. It will say how strong the measurement, how strong these two variables are correlated. So it is the value from -1 to 1. If it is positive value and the value is equal to 1, they are highly correlated. It's a perfect positive correlation. If it is -1, it is perfect negative correlation. So uh, I, the correlation coefficient 0 means that there is no correlation. So here is an example. So here we are getting the correlation as 0.9574, represent the attributes are much similar to each other. The next one is percentile. What do you mean by percentile? Say we used to say the term for student terminology, like 35 percentage of these students are below 50 marks. 75 percentage of these students are below 75 marks, and so on. So how do we calculate the percentile? See, we can easily implement these methods in our IPython or in our Python language. We have so many packages which supports how to calculate percentage, but we should know the mathematical meaning behind that. Based on that, we can easily provide the inference. So I'll tell you how to calculate the percentile. This is an formula to calculate percentage. If I want to calculate percentile pk, means let's say 50th percentile or 75 percentile and so on. K represent the percentage that you want to calculate divided by 100 into the number of samples that you have in your data set. So I represent the calculated value. If your I value is whole number, okay, you have to go to that observation, means that data point, and the next data point, and the average value will be the result of that kth percentile. Okay, I will give you an example. Here you have 25 test scores. You first have to arrange it in ascending order. After arranging these 25 test score, I have it like this. And I have to find out the rank. How do I find out the rank? The formula is percentile k divided by 100. I want to identify 60th percentile. So 60 divided by 100, I will get 0.60. So then you have to multiply it with the number of samples. There are 25 test scores are there. So 0.60 into 25, you will get the answer as 15. So you have to identify the value at the 15th position. So in the 15th position, you have the value 79. So if your rank is whole number, 15, its whole number, your 60th percentile will be that value, the value at 15th position, and next position's average. So value at 15th position, it is 79, plus the next position value is 85. The average of this is 82. So I can conclude that 60 percentage of the scores are less than 82 marks. This is how we have to provide the inference. 60 percentage of the scores are less than 82 marks. This is about percentile. I think it is clear. Suppose if I have the rank as if it is not as a floating point value, it is not a whole number, what shall I do? So here we have an example, grades of 15 students. You have to find the 80th percentile. First we have to arrange it in ascending order. Then you have to calculate the rank. You are getting it as 0.80, and you have to calculate the 80th percentile. It is giving 9.6. So here 9.6 is a fractional value. It is not a whole number. What you have to do, you have to make it as the round to the next highest value. So you will get it as 10. So if you are getting this value as fractional, you can directly take the value which is in the position 10. So in position 10, you have to search it from left to right in the ordered one. You will get 85. So what you can conclude, 80 percentage of the grades are less than the mark 85. Okay, 80 percentage of the grades are less than the mark 85. So this is how we have to calculate the percentile. The next one is quartiles. So quartile is we are dividing the data into equipartitions, equal parts. So if we have the data for a particular attribute, let's say that particular attribute is having 100 percentage of data. So how do we partition that? Either we can partition into 2, or we can partition into 4, or we can partition into 10, and so on. So here quartile, we make the data set, or we make the particular features with 3 split points. If we make 3 split points, we get 4 equal parts. We say it as 4 quartile. So what are those things? The first 25 percentage, we say it as first quartile. 50 percentile, we call it as 75. The next 75 percentile, we call it as third quartile, and 100 percentage, we call it as fourth quartile. Okay, we will see how do we calculate all these quartile, and I'll conclude why do we need to do all these things, how it is helpful for pre-processing also. I will come to the point. So as I told you, we have calculated range. How do we calculate range? Range is the difference between the maximum value for the particular feature minus the minimum value. Suppose if we have outliers for students mark, say marks can be a positive value. It should be from 0 to 100. Suppose I have value 200 and the minimum value is 7. The range is very high. So using range as one statistical measure for our work is not correct. So what shall we do? We have to overcome, or we have to remove or identify the outliers and remove those outliers. So one such mechanism for identifying and removing the outlier is interquartile range. We call it as IQR. So what is this interquartile range? What is the how are we going to calculate this interquartile range from quartile? So this is the difference between Q3 minus Q1. Q1 we know that it will just take care of first 25 percentage. Q3 will take care of first 75 percentage. So when you want to consider IQR, which will just take the middle 50 percentage of the data. Okay, it will not consider the value beyond that particular range. So this is the another measurement. We can take it instead of range. IQR can be the better measure. So there is an example. How do we calculate IQR? So first of all, how do we calculate Q1, Q2, Q3? Based on that, we will calculate the IQR. So here is an example. First of all, you have to arrange the data in ascending order. So once you have arranged, first you need to identify the median. We know how to identify the median. So here the median is 3. So this median, let us consider this is the 100 percentage of data. Let us consider this is the 100 percentage of the data. The first median is nothing but our Q2. When you identify the median of left half, we say it as Q1. When you identify the median of second half, we say that as Q3. The difference between Q3 and Q1 is nothing but your IQR. So we calculate how are we going to get Q1, Q2 and Q3. So our Q2 is 3. In the left half, the median is here. How do we get the median? Yeah, so 2, 4, 6, 8, 10. Actually even number of values. So how do we get the median? 3 plus 4 divided by 2. When you round off, you will get 4. So you are getting the median as 4. Okay, either you can take the next value or the previous value. I'm taking the next value as 4, and the median of the first half is 3. So this is Q1, 4 is Q2, and the median of the second half, the average of these two, so it is 9. So Q1 is 3, Q3 is 9, interquartile range is Q3 minus Q1, you will get the answer as 6. Okay, fine. How this is useful, where we are using it. So we will see that. I'm going back to the implementation part. Um, can you able to see the IPython notebook? Can I get your
Yes,
response?
yes, madam.
Okay. Just a minute. Okay. Is it visible now?
Yes, ma'am.
Yes. So I would like to give you the demonstration of where we are using these mean, median, mode. How are we going to fill the null value? How are we going to identify the outliers using interquartile range and so on? So for doing this demonstration, first of all, we should know where are we going to collect the data. Suppose if you are new to this machine learning course, you first know which are all the place we have the standard historical data. You can find the data from UCI repository. So you have all the you have many data, data in this UCI repository. You have healthcare related. You have um, uh, yeah, you have all the historical data with various applications. This is one such repository that you can use. The another repository is your Gaggle. So where you can find so many data set. They are nowadays they are providing so many contests. You can find the data set in Gaggle as well. You have separate link for data sets, and even you can find the code and discussion for that particular contest. So it is loading for me. You can sign in to Gaggle, Gaggle.com. You can sign in. Then you can download the data set for the application that you want. There are so many sites where you can find out the repositories. So yeah, Gaggle, I'm showing you various applications, all dataset link. You can click, or if you want to, yeah, we have COVID-19 dataset. You have credit cost spending habits in India. Um, so many applications. You can open it and you can see the requirement. You can understand the dataset, and you can download it and you can use it for your process. Now I'm going to give you the demonstration in IPython notebook. So you have to use Colab for this, Google Colab, Google Colaboratory, and I have created new IPython notebook, and I have already coded it because the limited duration. So I just have to run it and show you how these statistical measures plays a role in pre-processing. So, first of all, before you move on to it, I understand that you have the knowledge with respect to Python packages. So, one such package is called pandas. So, pandas, which will process the structured table. It's a data frame which will which will do the statistical analysis or data processing on the structured table. So how are we going to do that? So here I'm going to take one example called housing data. I will open it and show you what is this housing data. Yeah. So this is our housing data. You can see it is a CSV file. It is not the structured file. It is a CSV file. So what you have to do is, first of all, you have to download this housing data, whatever data you want, whatever data set you want, you have to download it, and you have to put it in the place where your IPython notebook is available. So once you have placed it in that particular folder, you have to mount that drive. Okay, then you have to copy this particular file, and you have to read that particular file by using read underscore CSV function, which is there in pandas library. So once you use this particular command, it will just convert the CSV file into the pandas data frame. So pandas data frame, in the sense, it will have the values in the form of rows and columns. It is in the form of structured table. Okay, fine. So once we have the data set loaded into our IPython notebook, how are we going to handle the missing value? Many of them, I hope you have already learned data mining. If you see, there are two methods you can fill the missing value. One is our imputation technique. Another one is dropping that particular record or the column. So we usually will not encourage the dropping method, because if you drop that particular data, it means you are actually losing the training information. So most of the time, the researcher will not do this dropping of records. They will go for imputation. So how they are going to fill the missing value? Using some statistical measure. So we'll see how it can be done. For that, I am taking a data set called placement data set. I will show you the placement data set. Look into this. I have imported all the supporting packages which are needed for my implementation. Pandas I have explained where you can do the data analysis, data processing in the structured data. uh, Means you can load the data in structure format like your table, and you can do all the processing on it. And matplot library function have the pyplot sub package that I am importing all the supporting functions of pyplot. And cbon is also another visualization library. I'm importing all the supporting packages of cbon. So now I am loading the placement data set, which is in CSV format. I am loading it in the form of data frame. So data frame is a structured way of representing the data. So once it is loaded, I'm using a head function to display the first 5 rows of the data set. So what is this particular data set is actually? Based on the your educational details, you are they are going to predict the salary, how it can be done. So what are all those attributes? So whenever you do the analysis, first try to understand the get the domain knowledge about that particular data set. What is the gender? And this is SSLC percentage, board, higher secondary percentage, board, what is the stream, degree percentage, what is the technology that they have learned, and so on. You have so many features to predict the salary of the person as the data set. Now we are not talking about prediction. We are just focusing on the pre-processing technique. So in the upcoming classes, the other resource person will be taking about the prediction and so on. So first of all, I should know the size of the data set. How do I know that? There is a command called shape will give you the size of the data set. Here it gives 215, 15. It means that there are 215 records and 15 columns. I just want to describe the statistical. I need to summarize the statistical measure. For that, a single command describe. We have seen all these command with full explanation, the mathematical meaning, but the package does in a fraction of seconds. The first one is count. How many records are there in this particular attribute? How many records are there in this particular attribute, and so on. If you look into this, the shape of the data set is 2 and 5. The count of the records are 2 and 5. For for salary, it is just showing 148. And also the statistical measures works only on the numerical data. Take it SSL, your secondary percentage. Okay, it is just taking the numerical attribute. It is not taking the categorical attribute. So when you want to give it a machine learning algorithm, you have to convert this categorical attribute into the numerical attribute. That is also one type of pre-processing. And if you see, certain attributes are having missing value. So how do I handle this? That is one point. I'll be handling that. Mean. So mean of every attributes are being displayed. This is how spread the data with respect to mean, that is variance. The standard deviation is also represented here. The minimum value is also represented here. 25 percentile, 50 percentile, 75 percentile. I already told the meaning. Here the 25 percentile for SST percentages. 25 percentage of these students are less than 60.6 percentage. Okay, 50 percentage of these students are less than 65 marks for higher secondary percentage, and so on. So this only once you able to make the inference on the numerical result that you are getting, it is better, the best way you can provide the inference about your prediction. Next, I am going to identify the null value. So in this statistical description as well, in itself, we have identified the null values are there in salary. If you want to identify the null value for all, including the categorical and all the attribute, we have to use is null function and count the null value. If you see only salary is having null value, all others are not having null value. So how do I approach this salary? How do I fill these null values. For that, I'm using central tendency measures, mean, median, and mode. How do I do that? So if you remember, there are two ways you can apply the statistical measure. I mean, filling the null value. One is based on the scale, another one is based on the distribution of the data. So now I am going to tell you, here you have the salary as get a continuous value attribute. Okay. Okay, fine. Next one, we are going to plot the distribution of the salary data set. For that, I'm using SNS plot, dist plot to plot for the attribute called salary. So here PLT is the alias name for SNS plot, and I'm giving the figure size as 8 cross 8, and I'm going to use dist plot, distribution plot, to plot the attribute called salary. So when I do this, you could see you have the mean around 0.25 something. There is a peak, and you can see few outliers are there in the right side. So it is not following the normal distribution, it is skewed, right? It is skewed towards the right side. It is positive skewed, it is not negative skewed, it is positive skewed. So if you have the skewed, okay, you should not use mean for your filling the missing value. I told you, if the attribute is continuous valued, you can use either mean or median. But again, there is a confusion. Which measure shall I use? If your distribution is normal, symmetric distribution, you can go with mean. Here it is not a symmetric normal distribution, it is skewed. If it is skewed, you can use the median measure to fill the missing value of the salary. So how do I use it? You go to the salary of the data set, fill the missing value of salary using median. Okay, you know how to use median. So the package will be taking care of it. It will sort the data in ascending order and find out the mean. You know how to find out the mean. If it is even number of values, how to you have to take the average of two mid values. Otherwise the mid value for odd number of values will be taken. So after filling the missing value, you if I run is null sum function, you could see there is no missing value at all. I'm just running it. I have to run all other things. Okay, let me just run all. Yeah. So now you can see there is no missing value at all. Okay. So this is how you have to choose filling the missing value. If it is nominal data, nominal or ordinal data, go with your mode or median. If it is continuous value data, you go with mean or median. Okay. So if which measure out of this one has to be taken, you have to decide based on the distribution of the data. If it is symmetrically skewed, if it is symmetric, then you have to use mean. If it is not symmetric, you have to use median for the continuous value data. Hope this is clear. I just want to go to the second method of handling the missing value. For that, you have to use dropping method. But we usually will not encourage the dropping method. But I will tell you, if you have huge amount of data, if you feel that the dropping will not affect my performance of this model, you can go for dropping of data. So I'm just running this part. So I have loaded the placement data for my work. So the shape of the placement data is 215 records with 15 attributes. And I'm checking whether we have the null value in this data. Yes, we have 67 null value in the placement data set. So I am going to drop those missing value. For that, I'm going to use the function called drop NA. Okay, so there is a salary data set. You are going to drop any records having the null features or null value for an attribute. So this is how the missing values are removed. So now if I check for is null function, there is no missing value at all. Now you could see the shape of the data set is 148, 15. Before it was 215, 15 because we have removed 67 records. But usually this dropping methods are not recommendable. Please go with filling the missing value with any of the statistical measure called mean, median and mode. But there are many researchers, they are doing filling the missing value with regression analysis. For that you should know the machine learning algorithm. You can predict the value of missing cell based on the regression technique. Okay. So the next one, we are going to remove the outliers. Outliers is a major thing because first thing, if you have missing value, you know how to handle the missing value. Second one, you should be very careful about the outliers, which will change the entire prediction, entire result, and which will slow down the accuracy of the model. So how are we going to identify the outliers? What are the different mechanisms are there to identify the outliers? How are we going to remove those outliers? There are three mechanisms which are there to identify the outliers. One is the interquartile range. Another one is our box plot. Next one is our scatter plot. Next one is our histogram. Box plot, scatter plot, histogram, all clustering mechanism, all will give you the outliers. So I am just going to give you few method. How are we going to identify the outliers? So we know how to calculate IQR. IQR is the difference between Q3 and third quartile value minus the first quartile value. For that, I am loading the Boston dataset. Boston is the house pricing dataset. We are going to predict the price of the house based on the crime rate of the city, how many rooms the house is having, what is the percentage of tax they are paying it for the house, and what is the which zone it is available in the city, and so on. So I'm loading the Boston dataset. So the Boston dataset is already available in the package called sklearn subpackage dataset. So from the sklearn subpackage, sklearn dataset subpackage, I'm importing load Boston. I'm importing the dataset called Boston dataset, and I'm using sklearn. I'm importing all the supporting sub packages of sklearn, pandas to do the analysis on the data frame, matplot library to see some visualization for our inference. So I am loading this Boston dataset. I'm naming it as BOS underscore BOS underscore HOU. I'm just extracting the feature names as the column name, and those column name I am making it as the data frame. So now I am printing the first 5 records of my Boston housing data set. I don't have the price attribute. Price is the target attribute. I have not loaded the target attribute. I just have loaded only the features. Okay, I have not loaded the target attribute. So I have the data set with first 5 records because I have used data frame name dot head. Okay, next one, I just want to know all the information about the data frame. So if you take the data frame contains 12 at 13 attributes. So look at the index, it is from 0 to 12. Okay, and it is having 506 entries, where the index of the entries are 0 to 505, and there is no missing value at all because all the 506 values for these attributes are non-null, means it is having some value. All the values of data type flow 64. Hope this is clear. I'm going to build a box plot. So before I move on to box plot, I should explain you how this box plot works, the visualization technique. So box plot, it is a 5-number summary of the data set. Those 5 numbers are minimum, Q1, median, that is our Q2, Q3, and maximum. So minimum, we know how to calculate minimum. We know how to calculate maximum. Q1 is our 25 percentile, median is our 50 percentile, Q3 is our 75 percentile. So if the value which are going beyond these range will be our outliers. I'll tell you, using this 5 number, we can plot the box plot. We'll see how we can plot this. This is our box plot. Box plot is actually only 3 numbers, Q1, Q2 and Q3. And the extending the box plot, we call it as whisker plot. Sometimes in most of the books they say the entire thing as the box plot, the minimum and maximum value. So our aim is to identify the outliers beyond this range of the maximum and minimum value. If some data points are above the maximum or below the minimum, we are going to remove, we are going to consider that as an outlier and we are going to remove it. So one such way is if the value is greater than 1.5 times of IQR or lesser than 1.5 times of IQR will be considered as an outlier. We know how to calculate IQR. Q3 minus Q1 is our IQR. Multiply it to 1.5. The value which is above or below 1.5 will be considered as an outlier and we can remove that. Okay. Fine. So this is a simple example for how to identify 5-number summary. First of all, you have to take the data. So in order to identify the median, you have to first sort it in ascending order. You know how to identify the median. Here it's even number of records. So you have 10 records. So first median, that is our Q2, is 30 plus 34 divided by 2, that is 32. Next, you have to identify the first quartile. The median is 29, that is Q1. The right side, the median is 35, that is Q3. Minimum is 25, that maximum is 38. So we have all 5 numbers. The other example, you can go through this slide later. So now you have to plot a box plot. You know Q1, Q3, Q4, sorry, Q1, Q2, Q3, minimum and maximum. Suppose if you have symmetric box plot, this is the way you have to represent the symmetric box plot. This is positively skewed plot, that is negatively skewed box plot. The value which are falling after this box plot, this one and this one, are considered as an outlier. Okay, so the visualization technique also helps us to identify the outliers. We'll see how are we going to identify the outliers and how are we going to remove the outliers. The second one, the second mechanism to identify the outlier is histogram analysis. So we all know that the histogram is used to summarize the continuous or discrete value data. So it is the visual representation or specified as the bins. So we have the number of data points. We have to provide the specific range. In that particular range, how many values are coming under will be taken as the bar. So now look into this. Usually this is like a bar chart, but in bar chart we have the representation for individual value, but here we are having it for range of value. In bar chart we have the gap between the histogram bars, but here we don't have the gap between the bars. So I will give you an example. Usually if the histogram is like this, means the distribution is normal. It is means you can analyze, you can say that the data is following normal distribution. You can proceed with the analysis. If it is having bimodal, you can say that the data distribution is 2 separate group. You can analyze the data into 2 separate group. This is left to skewed, sorry, right skewed. This is left to skewed. This there is no, this is a random distribution, means there is every data is following different properties. So it is difficult for you to analyze everything. You have to analyze it separately. Let us have an example for histogram. We have seconds, waiting time of the customers in seconds. So I have plotted the graph. If you could see in 33 to 38, how many customers are waiting? From 38 to 43, how many customers are waiting, and so on. So if you look into this, Based on this data, I have plotted a histogram and I can come for the analysis that 3 customers are waiting between 1 and 35 seconds. Okay. And 5 customers are waiting between 1 and 40 seconds. 5 customers are waiting in 1 and 45 seconds and so on. Okay. So this is how you can provide the inference. Finally, I can say that majority of the customers are waiting between 35.1 second to 50 seconds. Suppose if I have any customer between this range, say in 5 seconds or in 80 seconds, those are not following the properties of these. They are just deviating from this particular group and we can consider those things as an outlier. Next one is our scatter plot, which will give you the relationship between two numerical attributes. Okay, whether it is positively correlated or negatively related and so on. There is no correlation and so on. If you look into this example, it's polynomial, it's a curvy correlation. So, see between 40 to 80 increase in unit price, the item sold also increased. But after 80, if the unit price increases, the item prices are um, the item sold are reduced. So this is how you can provide the relationship between two attributes. So this is the another example where you have the positive relationship. So there are different way. This particular plot will tell you how these things are correlated. In this correlation, suppose if you find some data falling here and so on, suppose you have the data points placed here, these positions, I can say those points are those data points or outliers, and we'll see how are we going to handle those things. Okay, I will go to the implementation again. So you know how to plot the how to identify the box plot. So I'm directly using the box plot from Cbond, that is SNS package. Cbond library I'm going to use. You could see this is minimum, this is Q1, this is Q2, this is Q3, this is maximum, and these 2 points are outliers. I want to know what are all these data points. So position of this outlier, I want to know those records. So I have identified those records. The record with the index 351, 352, 353 and 354 all having are all outliers. So how I am going to identify the outliers using scatter plot? I am providing the relationship between two variable, index and tax. So if you could see, most of the values are between 0 to 15 and few values are lying 20 and 25 for the full value property tax rate. So I can see these values are outliers. You can as well print the position of those records. Okay. And the other one is Z score. If you remember, I told you if the data is falling beyond 3 standard deviation, after 3 standard deviation, you can consider those things as an outlier. So that I have identified by using Z-score normalization or Z-score standardization technique. So these are all beyond 3 standard deviation. So I have identified the record which is having the outliers. The next one is our IQR. I told you 1.5 times of IQR. The value which is below or above 1.5 times of IQR can be considered as an outliers. So I have calculated IQR, which is the difference between Q3 minus Q1. And I have calculated the lower bound and upper bound, multiplying it with 1.5 times of IQR. And I have identified the rows which are having the which are considered as an outliers. So we have identified multiple mechanisms for identifying outliers. We will see how to remove these outliers. So for removing these outliers, this is best way, as I told you, IQR mechanism, which is above 1.5 times of IQR or below 1.5 times of IQR, you just have to drop those records. So you are dropping those records which is below and above the IQR value. Hope this is clear. I'll be sharing this IPython notebook. You can execute and see. And coming to our next part is our rescaling mechanism. So why are we going? This is also one type of pre-processing technique. What is the rescaling mechanism is actually, if you have the data set with multiple features where every feature values are measured in different scale. 180, one is having the unit scale, another is measured from the scale of range between 0 to 200, one is 1000 to 200. If you have the value which are not following the standard scale, definitely it will affect your prediction. So how do I make it proper? How do I make it in the particular range? We can use multiple scaling, a standardization mechanism. One is our min max. You can make every value into the range between 0 and 1. So this is the formula for doing that. Maybe you might have already studied it in data mining and warehousing. So I'm just skipping this. So if you could see, I have minimized, or I have rescaled the data, or I have rescaled the features age and height between the range 0 and 1. So this is how why, which are all the application it requires. Maybe when you learn the machine learning model, you could see in neural network you'll be having uh, uh, the signum function at the end, which will scale your data from 0 to 1. There are multiple applications where this min max scalar works. So the code for min max scalar is available here. So you have to download the you have to import the package min-max scalar from the root package called sklearn.preprocessing, and you can do the min-max scalar. You have to use fit and transform mechanism. What do you mean by fit and transform? Fit will do the analysis or calculation of the difference between the value with the range that you want to transform, and once the analysis is being done with that particular technique, it will transform that into that particular resultant value. Next one is our score standardization, which is very important. We always these data analysts always see check whether the data follows the normal distribution or not. So when you want to check the data which is following normal distribution, so you have to use you have to first standardize your data. So for that you are using Z-score standardization. So what is this Z-score standardization? You have to having your mean as 0, standard deviation as 1, which follows the normal distribution. So what is the formula that we can follow for Z-score standardization? X minus mu divided by sigma. This is how you can do the Z-score standardization. So this is when you have the data follows this Z-score standardization, you can say the data following normal distribution with these standard deviation ranges. The value which is falling beyond the standard deviation, I can say that it is outliers, and we can remove that as well. Okay, fine. You can, these are all sample examples and calculations. So now you can see I have gathered the data having the mean and standard deviation like this. After Z-score standard deviation, you could see the data is following mean 0, standard deviation 1. So I can say the data is now following standard normal distribution. The next one, binarization. So as I told you, whenever you collect the data, you may have the data with categorical attributes. So how do I analyze those categorical attribute? How do I convert those categorical attribute into numerical value so that I can use it for my machine learning algorithm? So one such technique, we call it as binarized data. Suppose I want to make all the data in binary format. How do I do that? Very simple. You have to fix the cutoff. The age after 40, you can make it as 1. Greater than 40, you can make it as 1. Less than 40, you can make it as 0. Binary. Salary greater than 58,000, you make it as 1. Less than 58,000, you make it as 0. So this is how you can binarize your data. You have to select these things based on the application. Another one is our label encoding. Label encoding will just label the data 0, 1, 2, etc. But the problem is it will just simply label based on the alphabetical order. But when we make it as 0, 1, 2 as the number, the weightage of 1 is greater than the weightage of 0. The weightage of 2 is greater than the weightage of 0 and 1. It doesn't mean that that particular category is having more weight. So a label encoding is not the right way of doing. So we have to go to the mechanism called one hot encoding. So what this one hot encoding is actually does. If we have three categories, green, blue, yellow for color, which will the one hot encoding will create three more attribute and have the encoding mechanism like this. So if I take color 0 as green, color 1 color 0 as blue, color 1 as green, color 2 as yellow. So it will create three again new attribute. Blue is considered as color 0, green is color 2. So color 1. So in your color 1 you could see there is an entry because the color green represent it is available in this particular record. Remaining all colors are 0. Coming to blue in the second record, color 0 alone 1, remaining all 0. Same thing for 2. So one hot encoding is a better mechanism compared to label encoding, because when you have multiple categories like size of the shirt from very small to extra large, you may have 5 to 7 different categories. If you rank it, that is not the right way of doing it. So better you can go with one hot encoding. Now let me again go to the implementation part. So I am giving you how to do this data standardization. So for that you have to import the packages. So I have imported NumPy to perform some numerical operations. Pandas are working on the data frame, and I have loaded the data set from sklearn data set. That data set is breast cancer, identifying the person is having the cancer or not. And I am importing the standard scalar function to do the standardization technique. Very important thing, before once you have completed data pre-processing, you have to apply the you have to give the data into the model. For that you have to split the data into the training and testing format. So how do I going to split that? So now I am loading the breast cancer data set from the sklearn package, and this is my data set. It is like key value format. It is like a dictionary format. It is not in the data frame format. So you have to convert that into the data frame format. So I'm taking all the feature names. I'm taking all the feature names. I'm not taking the target names. I'm just taking only the feature names. I'm loading it into DF. I'm just displaying the first 5 rows of your breast cancer data set. If you look into it, at the end, I don't have the class attribute. I have all other attributes in my hand. I want to know the shape of my data frame, which is having 569 records with 30 attributes. I want to load this particular data frame into the variable X, means all the features alone in X and class label in Y. So look at it, I am printing both X, which is having only the features values, Y, which is containing only the class label. Okay, hope this is fine. Now I am going to standardize the data. If you look at the data, few attribute values are like this, few attribute values are 0 to 1 scale. uh, it is not in the standardized scale, right? So I am going to standardize this. See how I am going to standardize this. I will tell you this splitting of training and testing little later. I will just complete this standardizing the data. So how I am going to standardize the data? So you have to first I'm just printing the standard deviation of the original data set. It should be it is actually 228. So if you remember, for the normal distribution, the standard deviation of the data set should be 1 and the mean should be 0. But if you see, the standard deviation is 228. It is not following the normal distribution. So you have to standardize the data. Some problem in your data set which will definitely affect your prediction result. So what shall I do? I have to apply standard scalar function. So I am going to analyze. The fit function will calculate the mean and standard deviation of your data set, and this transform function will convert the data into the standardized format. Now I am printing the X train. You can see all the data between -1 to 1. Hope you can see this. Okay. Now you can calculate the you can calculate the standard deviation of the training record. Now it is 1. So the standardization plays a major role in your pre-processing technique. The next one, how do I divide the data set into training and test data? So we all know that if I have 100% of the data, you'll be splitting first. You can follow 80-20 rule, 70-30 rule, 60-40 rule, or you can use hold out method, or you can use cross fold validation and so on. Now I'm just giving you how we are going to split the data in the normal division like 60-40. So what I have to do is I'm just taking the data set. Here you know that X is containing, I'm just going back. Here X is containing all the feature values and Y is containing the target value, right? So now before the standardization itself, I am going to split training and testing. I'll tell you the reason why I am doing that. So here you have to call the function called train test split for the feature as well as target. You have to have test size as 0.2, which means we are following 80-20 percentage. 80 percentage training data, 20 percentage test data. Here I have one more attribute called random state is equal to 1. Random state which is non-zero, whatever it may be, one, most of the test, most of these data, most of the data mining algorithm with various application, random test 32 is the best one, they said. I'll tell you what is random state first. When if you run this particular program for n number of times, the random sampling that is being done for splitting 20 and 80 percentage is same for every run. If I use 0 or if I use none, every time you will get different accuracy, but that should not be the case, right? Every time when I run, I have to work it on the same training and testing data set. So that is how this random state is being mentioned. So this uh, X 80 percentage is stored in X train. X remaining 20 percentage is
Hello. Selvi madam, you are not audible. Hello. I request to wait. Kindly wait. Sometimes the research person side there is some technical glitches on there. Kindly wait 5 more minutes.
I joined back.
Okay, thank you, madam. You can carry on.
Yes, I'm going back. uh, can you able to see my screen?
Yes, madam. Proceed.
Okay. Okay. So I actually uh, I actually completed till splitting the training and testing data. After splitting, if you see, initially it was 569 records. After splitting, you can see the shape of X shape, X train and X test. That
Hello, madam.
569. Yeah, yes, sir.
Sorry for the interruption. Actually, we are seeing your mail data instead of the collab.
Oh, I'm sorry. I will share it again. Is it visible now?
Yes, ma'am.
Okay. So after splitting, you could see the shape of the original data set is 569 records. After that 80 percentage and 28 percentage of split, you can see you have 114 in test and remaining all in train. After you do the split, please do the standardization. I will tell you the reason why we have to do the standardization after splitting. So we have to do the standardization with respect to the mean and standard deviation of the data. So when you standardize the whole data, you are calculating the standard deviation for mean standard deviation for whole data. When you train the model is trained with the value of those 20 percentage as well. So it knows the type of value which cannot be the unknown data given for testing. So that is the reason we have to do the standardization after you do the splitting. So now you look at it. I am calculating the mean and median of X train, and I'm transforming it. Now you can do that. Now you can see the data for X train, standardized one. And when you do the standardization for test data, you should not use the mean and standard deviation of the test data. Instead, use the mean and standard deviation of the training data, because the ultimate aim of analyzing or ultimate aim of making the machine to build from training data and test it with test data is the test data should be unseen one. So how can I make it as unseen one? You standardize your test data based on the mean and variation of your trained data. So if you do that, definitely your model will not give 100% accurate, which will not be biased towards your particular feature of your data. So please don't do the transformation for tested data on its mean and standard deviation. Do it with respect to the training data's mean and standard deviation. So this is how you can do the training and test split. If you now look into the standard deviation of training, it is 1, but the standard deviation of testing, it is not 1. Yeah, I have to run everything. The standard deviation of test 1, it is not 1. I will give you how much it is. You can see it is 0.96 because I have standardized based on the training set value. I want to show you the demonstration of the label encoding. I have taken the breast cancer data set. Can I take another 15 minutes? It is already 4:05. Sir, can I take another 15 minutes?
Okay,
Okay.
madam.
Yeah, I have to show you a few more pre-processing techniques. So now I'm loading the breast cancer data set. These are all the first 5 rows of the breast cancer data set. You have various features. Finally, you will be detecting whether the person is having breast cancer or not. So if you look into one attribute called diagnosis, this is the class attribute, benign and malignant. So whether the person is having breast cancer or not. So if you look into it, these values are categorical. So you can use label encoding to convert that into a numerical value. So how do I do that? So for doing that, you have to call the label encoder function. You have to fit label encoder will analyze the data, how many categories are there, and then it will transform into the labels. We'll see how the labels becomes. I will give you the output. I have labeled this diagnosis as target. You could see one attribute called target where M is represented as 1 and uh, uh, benign is represented as 0. Hope this label encoding is fine. But if you have multiple categories, don't use label encoding. Please go with one hot encoding. Okay. The next one, I would also like to show you the label encoding for other data set, iris data set. So this iris data set, yeah, I'll just load this. Yeah. So this iris dataset is having 3 different classes: iris, setosa, versicolor, and virginica. So I cannot use label encoding because I cannot differentiate with multiple orders. For that, I am using. I will show you both label encoder and one-hot encoding. So the label encoder, after fitting, it is giving the result like this. You can see iris setosa as 0, iris versicolor as 1, iris virginica as 2. But there is no ranking like this. Please don't do that. You can do one-hot encoding by using one-hot encoder function instead of label encoder function. That's it. The next one, I already given you the train test split. This is the another example. You can go through this IPython notebook. I'll be sharing this to you. The next very important thing is imbalanced in the data set. So how do I take care of this data imbalance? Let us consider one example. This is credit data. I'll just load this data. So imbalancing is nothing but one class is having more number of records where the other class is having less number of records. So if you make your machine to learn from the historical data, it will learn with respect to one data and it will not learn the other data, which will overfit towards that data which you have given more. So whenever you give the data for learning, make sure that all the classes are equally distributed. All the records in the classes are equally distributed. That is very important. So in this credit data, you have multiple features. Since it is a financial data, they have hidden the feature names. And so we are not analyzing these things. We are just checking the balancing of the data. So if you look into it, in zero class, there are 4 lakhs 90, sorry, 49,461 record. In one class, you have 148 record. It is highly imbalanced. So one is represent the fraudulent transaction, 0 represent the legitimate transaction. So obviously what you have to do, you have to sample it. So you can go with multiple sampling technique. The basic one is your undersampling. Undersampling also you have various mechanism, sampling with replacement, sampling without replacement, so many things, so many sampling techniques are there. I'm just giving the demonstration for one sampling. We are going to do the undersampling. Undersampling in the sense I'm going to make this legitimate class equivalent to the fraudulent class. So I'm going to make 49,461 equivalent to 148. So for that you have to use the legit dot. This is the data frame name. You are calling the sample function and equating it to the number of records which is equal to 148. Okay, now if you look into the sample, it is 148 records with 31 columns. So after you done the undersampling, you join the legitimate class. You concatenate the legitimate class and fraudulent class, and you can do the remaining processing on it. So now if you do the value count, you can see both the records are having equal number of, both the classes are having equal number of records. This is about imbalancing of the record. So there are a few more thing that I would like to cover, how the processing is being done on text, and how the processing is being done on uh, images. I'll just quickly go through it. Can you able to see the IPython notebook for text pre-processing?
It's showing on numerical dataset pre-processing.
Okay, I'll unshare it again. I think now you can able to see.
Yes, madam.
Okay, sir. So for your text pre-processing, we have to have all the data in the form of text. So a text, we usually call it as corpus, which is having collection of documents, paragraphs, statements, and so on. So we have so many packages related to text, regular expression, NLTK, NLTK corpus, which is having stop word as one such package, quarter stemmer, TF-IDF vectorizer, and we know trained test split model, which can be imported from the library called model selection in SK learn. So I'm just quickly going through it. Uh, First of all, you need to download the NLTK stop words as a first step. Again, then I'm going to list out all these stop words that I have. So these are all the collections which are there already in the library, so you don't need to worry about it. If you want, you can as well insert some of the words that you feel. You can as well create the dictionary on your own. So now I am going to take the fake news data set, which is in the form of CSV. I'm loading it as a data frame, and this is the first 5 records I'm showing it over here. Here you have 0 as the class label, which represent it is a real news, 1 class label which represent it is a fake news. There are 20,800 records with 5 columns. Those 5 columns are ID, title, author, and text. The first thing I'm checking whether you have the null value in the data set. You can see title, author, and text is having the null value. So you, since it is not a numerical data, you cannot fill it with mean, mode, median. It is a text data, so I am filling all the missing value with a null string. So fill NA, this is the null string, or else you can give any keyword, none, NaN, not a number, not available, NA. You can give those things, but either or else you can fill it with the null string. Um, if you feel that I don't want author and title as a separate column, I want to merge it, you can merge it. So you can merge the 2 columns like this. The main important thing, I am just taking all the data column, which is title, author, and text and content. I'm going to do the stemming. Stemming is the process of reducing the word to its root word. Say you have enjoy, enjoyable, enjoyment, all those things enjoyed. You should have only one word as enjoy. So identifying the root word, you can do it by using stemming process. Okay, and you can remove these stop words, all those things, and finally you will have the record with the bag of words without any punctuation, stop words. You'll be having root words. You will not have any of the special character. You have all the words in the form of uppercase or lowercase the way you want. After identifying these bag of words, consider these words are an feature of the data set. Now you can make your unstructured data set into the structured data set, where the bag of words that you have identified will act as the feature of your structured data set. You can apply multiple way of filling the cells of your structured data set. You can use term presence. The word is present in record 1, make it 1. If it is not present, make it 0. Term frequency. how many times the word present in this particular row, a particular record, make that frequency, otherwise 0. Okay. As TF-IDF is, it represent the term, the frequency of the term across the document. So in this that is your term frequency divided by inverse document frequency. So you can use any of these mechanism and you can transform. Finally, you will have all the text value converted in the form of numerical values. Now the numeric, you have the structured data set. Now it can be ready to apply into the machine learning algorithm or any algorithms. Next one is your image. Uh, Image, you know that you have the pixels. First of all, you should remember whether are we going to process the color image or grayscale image or black and white image. So based on that, each and every pixel values are varying from 0 to 255, and that pixel value will be acting as the features for the structured data set. So I'll be sharing you the IPython notebook for processing the image data. Please go through that. In case if you have any doubt with respect to pre-processing of images, you can mail me. So I have the pre-processing of image data. How are we getting the black and white images from the color images, grayscale images from color images? How do we get the numerical data from the images and all? I'll share this IPython notebook. So the basic thing, whatever we have seen, is common for all type of data that we have. Any queries you can ask.
Thank you, Dr. Selvi. My participants, if you have any doubt, kindly raise your hand. I will connect to Dr.C. Selvi. I repeat again, if you have any doubt, kindly raise your hand. I will connect to madam. Madam, you can talk, madam. Ramya P. You can unmute and talk, madam.
Ma'am, it was a informative session. Thank you so much, ma'am. Ma'am, I have a small doubt. Am I audible?
Yes, ma'am. Yeah, you are audible. Please, ma'am.
Yes. Ma'am, my research topic is about analyzing the MRI reports, ma'am. So
Okay.
for that, actually, I was in the stage of pre-processing the images. So before that, I want to know the procedure, how we can actually we need to create separate folders for T1 scan, T2 kind of scan, and we have to keep it in our drive, and we have to mount the drive to our
Yes.
collab file.
Yes. Yes.
Okay.
You have to put it in the folder and you have to mount it in the IPython notebook where you are currently.
Okay.
Then you can use that path for loading the data set into your data frame.
Okay. Okay, ma'am. Fine, ma'am.
Yes,
And
ma'am.
another thing is that
Yes,
actually
ma'am.
from the base paper I have learned that on seeing the patterns it is going to identify whether the level of infection is high, low, medium or what.
Yeah,
And
okay.
what I thought is that the same scan, if it is taken 6 months prior and the current scan, if we compare these two, can we identify the level of infection, whether it is high or it is increased, whether the infection is increased or not? So for that, whether we can use CNN or RNN, ma'am.
So RNN, we can mainly use it for text based, but you analyze the features that are available in the images that you have. So it is like what is the number of training data set that you have, and usage of algorithm CNN and RNN, you have to test it with your sample data set.
Okay.
So I
Um,
cannot say you that you can go for CNN, you can go for RNN. It is all depends on the application and data that you have in your hand.
Okay.
Yeah.
Ma'am, to start with, what was the reasonable quantity of data that I can start?
uh, it is all based on the categories that you want to have. Suppose I want to classify it into two classes, and suppose if you want to identify whether the person is having brain tumor or not, make sure that in every class you have equal number of samples,
Okay.
that too more than 10 or 20,000 at the initial stage, and you can even increase in the further stage when you have the new set of data in recent years.
Okay. Can we use the data set that was available in the public
Yes,
repository
yes.
to
When you
continue our
actually, when
research?
you publish the data, when you publish the paper to some journals, they'll be asking you to provide the results in the standard benchmark data set. So it's
Okay.
better you test your algorithm with standard benchmark data set, and you can apply the same algorithm for the data that you are collecting.
Okay. Whether that public available data sets, the quantity, the number of images is more, can we reduce that to, we can take a 30% of the data? Or can we
Uh,
reduce that one, ma'am?
Reduce, you can reduce it, but that do you feel that 30 percentage of the data will covers all the information about the outcome that you are going to predict? If you feel
Okay.
that 30 percentage is enough, maybe you can proceed with, but for 30 percentage of testing or training.
But, training, ma'am, training. To
Okay.
start with, I'm telling. So once we start
Oh
with
yeah,
30
when you
percentage.
want to know the workflow of how the prediction is being done, you can start with the small data set, and you can
Okay.
increase it.
Gradual increase.
For
Okay,
initial
ma'am.
understanding, you can even test it with a single image.
Okay. Okay, ma'am. Thank you so much.
Yeah. Any other questions?
Okay, thank you, participants. On behalf of Department of Computer Applications, I express my heartfelt thanks to our resource person, Dr.C. Selvi, Assistant Professor from IIIT Kottayam, for sharing the wonderful demo on data pre-processing techniques, which is very useful for real-time implementation. Thank you for your valuable information, madam. Once again, thank you.
Thank you, ma'am. Thank you,
I
everyone.
thank, yeah, thank you, ma'am.